All right, today we're going to look at 6 rational exponents. I've kind of touched base on this a little bit before when we talked about 6.1 to 6.4. I briefly mentioned it in one of the lessons, but rational exponents can be used in place of radical symbols. And what we're going to do is kind of show you how they're interrelated. I know I showed you a bit last week as to how they're related, but we're just going to take this problem b to the 1/2 squared, okay? We understand at this point when we're dealing with powers, power to power we multiply, correct? Okay, we know those rules. All right, so power to power we multiply, which means we're going to wind up with b to the 1st as our answer, okay? Keep in mind, this is the same thing as the square root of b squared, okay? Right? If we square root, we wind up with just b as our answer. Okay? So kind of taking a peek at things. Hopefully you see the power is the same. So we're squaring both, which means we know b to the 1/2 must be the same as the square root of b, using our understanding of math. All right? And that's kind of the big thing right here. If you want to write it down, b to the 1/n is the same as the nth root of b, right? And some of you may have written that down last week again, but here it is for you, all right? So today is just going to be a lot of using rational exponents, okay? There's nothing super insanely complicated about the day, especially how we start here. We want to write this in radical form. So I'm going to have a radical. I need to put a number here, and I need to put a number here, okay? And then we have an a down here. Keep in mind, it was always 1/n. So this number in your denominator always gives you the index of your root. The numerator gives you the power, okay? So a to the 7/4 is going to be the 4th root of a to the 7. You could also write it like this. You could have the 4th root of a to the 7th power, okay? Either way, either of those give you the exact same result, okay? We want to be able to go backwards as well. So if I am given the 5th root of a squared, I should be able to convert that back to rational exponents. So this again, the index of the root is your denominator of your power. The power is your numerator. So we wind up with those answers going back and forth. All right. Continuing on, we're going to evaluate. All right. So it's kind of the same idea. I would always encourage you to do the root first and then do the power. So I would almost think of this problem as 625 to the 1/4 cubed. And the reason I like to do that first is mentally I can figure this out. I know the 4th root of 625 is 5. So then 5 cubed is 125. And then we take the opposite of it. All right. Just like on the next question, I'm guessing most of you don't know your 8th roots. Okay. But if I think about it this way, 256 to the 8th, what times 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 what gives me 256? Well, you're going to have to start small, correct? The 5th root of 256 is 2. All right. 2 cubed then is 8. If you need to use your calculators, you're welcome to. I would encourage you not to, but just make sure when you do put a rational exponent in, it should be in parentheses. Otherwise, you're going to get the wrong answer. It's going to do 256 to the 3rd power and divide whatever that answer was by 8. It's going to be wrong. Okay? So make sure if you are using your calculator to double check your answers, your rational exponent is in parentheses. All right. Kind of looking at the bottom, this is something we just kind of talked about and touched on. The numerator is the power. The denominator is the index of the root. So there's nothing really new in there to discuss. All right. Second half of the day is going to be working with operations with your radicals or rational exponents. Sorry. All right. So in this situation, when we multiply, remember we add our exponents. Okay, so 1/4 plus 10/4 is 11/4. All right. Remember, kind of thinking back to our properties of exponents, when we have a negative exponents, we flip. So I'm going to move b to the 5/6 to the bottom. Hopefully some of you are realizing right now that that cannot happen because technically I have a 6th root in the bottom. Okay, rationalizing with rational exponents is super easy. We want our powers to be integer values. And by integer, I mean whole numbers, especially in the bottom. So all I need to do is figure out what's going to get me to my next whole number, which in this case, I just need 1/6 more. I'm going to wind up with b to the 1/6 on top. Whenever we're multiplying, we add exponents, so we wind up with b to the 6/6, which is this b to the 1st. Okay? Just like with radicals, we don't want radicals in our denominator, but we don't want rational exponents in our denominator either. Okay? Continuing on. All right. Again, a couple different ways to do some of these problems. We can either simplify and then rationalize if we need to. Like in this instance, some of you might go to rationalize first. I would encourage you, since the indexes are the same, or indices, I'm not so good with words, are the same, we could combine it as a single problem. All right. We only can do that if they're the same. If it was like 4th root and the 5th root, we couldn't do this. But since they're both 4th roots, we can put them together. The 4th root of 16 is 2. Yay! All right. Looking ahead to the next one, simplifying radical expressions. We can simplify with powers or radicals. All right. A lot of this, again, is stuff you've done. We know 16 is 8 and 2. Cube root of 8 is 2. I'm going to take out one group of x's. That's going to leave me 1 left over. So I'm going to have 2 cube roots of 2x. Again, that's a problem we did very similarly in the last section here. Okay. And then this very last question. All right. So even though we have that rational exponent in our denominator, we do not want it there. Okay, so very similarly to our radicals in our denominator, we want to do a very similar thing with rational exponents. So when I have that expression in my denominator, I want to make sure to multiply by the same thing, just the opposite side, so that when I do multiply out, I'm going to get y minus 2y to the 1/2 plus 2y to the 1/2, and then minus 4. Those will drop out. Up top, we have a y plus 2y to the 1/2 plus 2y to the 1/2 plus, you can then combine like terms. So up top, we have y plus 4y to the 1/2 plus 4. And that's all over y minus 4. All right. Homework's on the bottom. Again, as you're working with rational exponents and radicals, make sure you have no negative exponents. You cannot have negative exponents in your denominator. You can't have a fraction within a fraction. That's a complex fraction. And you want any remaining radicals to be the least number possible. Okay. So if we had something, I'm trying to. So like if we had the cube root of 16, again, we want to make sure that this is 2 to the 4th. All right, we want to make sure it's as small as possible. So I could take out 2 cubed, or the cube root of 8, which is 2, and then I have the cube root of 2 left over. Okay. Homework's on the bottom. Again, if you want to use radicals versus rational exponents, you can flip back and forth as much as you want now. It doesn't matter. Do whatever makes the most sense in your mind. And then, yeah, if you're using your calculator to help you evaluate, just make sure your rational exponent is in parentheses. Otherwise, best of luck. Chime into the live session to ask questions or use the discussion board. I am here to